Hello. In this video we will discuss about that how to solve a transportation problem by using matrix minima method. So before discussing about the matrix minima method, we have to discuss or we have to know that what is transportation problem. The transportation problem, basically this is a problem where a particular commodity is stored at different warehouses, and we have to reach to the destination centers for by a minimum cost. Like here, see that in this matrix, that these rows, that is O1, O2, O3, O4, these are known as the warehouses, and D1, D2, D3, this is known as the demand. Okay, are the destinations. So there are 4 warehouses and 3 destinations, and see for O1 there are some amount I write here outside of the matrix. This is defined by AI, and this is actually known as the demand. This is actually known as the this is actually known as the supply, and this 767, this is defined by BJ, and this is known as demand. Okay, so now that means here how many warehouses are there? 4 warehouses and 3 destinations. Okay, and so now the number of solution for this transportation will be, that is, if there are m storehouse and n destination, then the number of solution will be m plus n minus 1. So see here that 4 warehouses and 3 destinations. So here the number of the solution will be 4 plus 3 minus 1, that is 6. So now the question is that how can we solve it? So before solution of this method, by using the matrix minima method, we have to check that this transportation problem is balanced or unbalanced. Balanced means here the supply equal to demand. That means here the total supply is 2 plus 4 plus 6 plus 8. So it will be 20, and the demand also will be 7 plus 6 plus 7, so it will be 20. That means here both these are same, so we can say that this is a balanced problem. So and these values, that is 2, 4, 3, 1, 5, 4, 2, 6, 3 and 4, 2, 5, these are known as the cost of the, this is known as the cost, and that's why this matrix is known as the cost matrix. So now the question is that how can we find the solution of this transportation problem by using matrix minima method. So here these are the supply and these are the demands. Okay, so now whenever we solve it, we have to follow very carefully. So now first we choose the minimum of this matrix, minimum cost of the matrix. What is the minimum? 1. Okay, so now say that 1. So now for 1, that is, it is O2 and D1. So now check that what is the demand. Demand is 7, and what is the supply? 4. That means here demand is greater than supply. That means we have to give here all the supply against this demand. That means here the demand is 7, but the supply is 4, so we have to supply it here first, all the 4 units are okay. So now whenever we give you the 4 units of the supply, so now it will totally obsolete, so now it will be 0. And see now that from this source we cannot supply to this one and this one, so this will all be obsolete. And now here this is fulfill the 4 of 7, so now 7 will be reduced to 3. Okay, in the next we have to find the next minimum. So now which one is the next minimum? See here, this is allocated and these two are already now exhausted. So now we will choose the first row, third row and fourth row. So between first row, third row and fourth row, which one is minimum? See here that 2 is minimum and 2 is located at every point. So now we can choose here arbitrarily. So here I choose the first row of 2 here. So 2 here we choose. So now see again, 3 is the demand, 2 is the supply. So here we have to give here the supply 2. So now these 2 will now convert to 0. These 2 will be 0 0, and now these 3 will be convert to 1. So now see that whenever we put here these 2 as the demand, as the supply is less than the demand or demand is greater than supply, so these 2 row now exhausted. So now only these 2 row are left, O3 and O4. So see now here that what is the minimum? 2 and 2. So which one is minimum now here? 2. So we can choose 2 by our own. So see here that if we choose these 2, what is the demand? 6. What is the supply? 8. So now here supply is greater than demand, so now here we can assign the total demand 6. So now it will be 0, and these 8 now up to 8. So now see here that here 6, this demand is fulfilled for this column, so now this column will be exhausted. So now only O3 and O4. So again, which one is minimum? 2 3 4 5. Which one is minimum? 2. What is the demand here? 1. Supply is 6, so we can assign here this 1, only the 1 demand is there, so now it will be 0, and now it will be now exhausted. And now this will be 6 will be converted to 5. So now see here that all these are exhausted and occupied, and now only these 2 are left. So between 3 to 5, which one is minimum? 3. What is the demand? 7. Supply 5. Give here 5. This is now 0. 2 is left here, 5. 2 2, so give here 2. And now see that there are 6 solutions, that is 1 2 3 4 5 and 6. And now what will be the solution? The solution will be and what will be the solution means here? The minimum cost. The minimum cost will be 2 cross 2 plus 4 cross 1 plus 1 cross 2 plus 5 cross 3 plus 6 cross 2 plus 2 cross 5, and sum up and you will get the result. So the solution will be 4 plus 4 8 plus 2 10 plus 15 25 37 47. 47 unit will be the transportation cost. So hopefully you understand. Thank you for watching the video.